Hi, my name is Nestor, and today we'll be going over Futex exploits, which are a Linux feature. Futex stands for a fast user space mutex, and mutex comes from mutual exclusivity, which is how we ensure that there aren't race conditions when we are running concurrent threads. So Futexes in Linux are implemented as a system call, and you use those to make locking threads. And each Futexes therefore has a wait queue, which is filled with waiters, aka process threads that are waiting for execution time. And there is a variety of Futex. It's called the PI Futex, Priority Inheritance Futex, which makes the wait queue operate more like a priority queue, where threads of higher priority execute before threads of lower priority. So, not every application has features or functions that require expensive calculations. So, like a game rendering the actual environments and geometry requires a lot of execution time. But, for example, updating the UI with simple information or just displaying like a character name would not require that much time. And futexes are the primary way that you organize the concurrency of your operations, whatever you need to do in the OS. It is built in by the kernel and extracted away from us high level programmers and users, and really dealt with only in like libraries and low level programming. So what is the vulnerability? Well, we have Towelroot, which is CVE 2014-3153, and it was an immensely popular method to root your Android device back in the day. If you look on YouTube, you'll find a lot of tutorial videos on how to root your Android using Towelroot from that time. And it took advantage of Futexes to escalate your user privileges to root. And if we look here, here's the key part here is that the Linux kernel did not ensure that calls have two different Futex addresses. And we're going to see how this creates a vulnerability and can be exploited. User Elongel on GitHub developed an exploit which I took a look at, and he had a corresponding blog post explaining everything. So he used two fake waiters, one to leak addresses and another waiter that corrupts the list. So the basic flow of the exploit is we need to lock a PI futex, wait on a non-PI futex with the intention of being requeued to the PI futex. Requeue the non-PI futex waiter onto the PI futex, set the PI futex's value to 0. Now, you're wondering, how can we set the value to 0? Well, if you remember, a futex is a fast user space mutex. So actually, futex operations happen mostly in the user space, which is why, as I understand it, we can set the value to 0. And then um, only when locks need to be resolved is when the kernel actually steps in. And then we need to requeue the PI waiter to itself. So let us see how this works really quick. So I have a custom 3.11.4 kernel that I compiled, and we are gonna just make it go into bin and run. Now, here's where it stops working. I tried to match what the author wrote. They didn't give too many details, only said that they used a 16.04 Ubuntu Docker container. So I got a i386 image, the same kind he's using of the 3.11.4 kernel that he ran this on. It didn't work, so but I still think it's an interesting topic and very technical. So I'll show you right now how this should actually execute. So we have a secret file, but we're a user, and then we run privilege escalation here. We escalate to root, and the root shell is pumped, and we're able to see the secret file. So here's the simplest explanation of the actual bug that occurs here that I can offer. So we have a non-PI Futex that we log to, and we have a PI one that we want to like self-requeue to. So without getting too deep into it, when we lock onto one and then declare that we're trying to acquire it, in waiting, we kind of manipulate the Futexes so that there's a dangling waiter. Uh, Basically, the order in which we do these operations prevents this our target Futex from uh, being deleted, and also so that the right Futex is at the top of the stack, so that when it's popped, we get an address exposed to us to a credentials struct, which contains root credentials for us to use to pop a shell, from which we can do essentially anything. Now, this isn't the end of it. Um, there are a slew of vulnerabilities related to Futexes. So I would say that Futexes actually are an example of a vulnerability coming from the design of the system itself rather than like human error or just like plain oversight. I would say that Futexes are the how Futexes operate are so complicated that it's not easy for anybody who is updating or maintaining the Futexes to prevent from new vulnerabilities from being exposed, because as in the video Futexes are cursed, is said, most of the Futex code is essentially kind of dealing with uh edge cases rather than, the normal case. So it has a pretty bad, edge case management problem, and is essentially, um I guess a necessary evil in because we need mutual exclusion, but few texts just continue to kind of be a problem. Of course, people who know much more about Linux than me may have other opinions, but the sense that I get is that few texts are really, you really just kind of a design that is vulnerable to having vulnerabilities, as funny as that sounds. So here are my references, and thank you for watching.